Welcome to Easy Math TV. We're going to continue to discuss probability distributions in this video. This time we're going to explore a distribution called the uniform distribution. There are two types of uniform distributions. One is discrete, the other one is continuous. This one that we're going to look at here is the continuous uniform distribution, and we're going to look at it using some R code here. So the first thing that I'm going to do is specify, or I should probably explain to you a little bit about what the uniform distribution is. The first thing that you do is you need to understand that it is defined on a closed interval of real numbers. So basically there's going to be a left value and a lowest value, and there's going to be a highest value. And those are your outcomes. So for the continuous uniform distribution on a closed interval bracket a comma b bracket, so that's how we describe a closed interval. First, we want to designate the values of a and b. So my first two lines of code here say a is equal to 0 and b is equal to 10. So basically, we're going to have values of x, our random variable x, will take on values from 0 to 10, including 0 and including 10. Then what I want to do for you is basically show up a graph of what that looks like. So underneath that, I'm going to type some more code here. We're going to graph the uniform distribution, what's called a density curve. So in discrete probability distributions, you can actually list the probabilities of all of the outcomes in the form of a table. But you can't do that with a continuous distribution. So the way to describe or show the probabilities for a uniform, for any continuous distribution, but including the uniform one, is to graph its density curve. So you're going to see what that looks like in a moment. So I'm defining my range of x values. The range of x values is just going to be b minus a. So it's the rightmost value minus the leftmost value. And then I'm going to just create a bunch of outcomes. So into the variable that I'm calling outcomes, we're just going to list in sequence from A to B, and we're going to count upwards by 0.5. So you're just going to get a list of values starting with 0, going up to 10, and incrementing by 0.5. So there should be 21 values altogether in that list. And then we want to calculate their probabilities. So their probabilities are literally just, because it's uniform, every single outcome has the same probability, and that is 1 divided by the range. So 1 divided by b minus a is going to give our graph for the density curve. And then we want to make sure that it only goes from 0 to 10, that it has the same number of things in it that our outcomes does. And then we're going to plot it, okay? So here's your plot. So let's just hit the run. And we're going to see what that looks like. So here's our, it's a pretty boring, it's probably the most boring distribution we have in the continuous random variable scheme. Because it's just a constant value. So all of the outcomes from x equals 0 to x equals 10 are equally likely. The definition of a probability density curve is, or in this case it's a line, would be that the total area under that has to equal 1. So this whole shape here is just a rectangle. So if you think about it, the width of that rectangle, or the width of the base of the rectangle goes from 0 to 10, so it has a length of 10. And the height of the rectangle is 1/10 or 0.10. So when you multiply the base times the height, you get 10 times 0.10, which is 1. So the total area is in fact equal to 1, and all of our probabilities are exactly 0.10, which means they all satisfy the requirement that all the probabilities must be between 0 and 1. So that's cool. That works out. So I just wanted you to see that that's what our population looks like. So now let's just take a sample from that and just take a look at what a sample looks like from that population. And then we're going to calculate some actual probabilities. So we're going to use this as a probability calculator for uniform random variables. So let's paste that. So let's generate a sample of 5,000 values from the interval bracket A to B. So in this case, the minimum value is our value of A that we specified, and the maximum value is our value of B that we specified before. So, once you type those in at the top here, that's just going to be consistent throughout all of our code here. And then let's make a histogram of that just so we can actually see what that looks like. And we're going to rerun our graph as well. So there's our histogram. So this is basically what a sample from a uniform distribution looks like. The rectangles are relatively equal in height. Like there can be some differences between them. But essentially, this is a histogram that has 10 bins. So we expect each bin to have a height of about 500 because 500 times 10 is our 5,000 values, Anyway, so that's what a sample would look like if it was from a uniform distribution. So suppose, using this distribution, suppose we wanted to know the probability of values between 2 and 5. So like just between x equals 2 and x equals 5, what is the total probability of that outcome? So what we're going to do is we're just literally just going to calculate the area. So let me show you what that code would look like. So I'm just pasting it in here. So we're going to type in our own numbers here. So we just need to make sure that they are in fact values between 0 and 10. If they're not, we're going to get some kind of an error message. So the left value is equal to 2 and the right value is 5. And we want to know what the probability of outcomes occurring that are between 2 and 5. So what you see here is the calculation for that. You basically take the right value minus the left value, and you multiply that by the probabilities that we calculated before, which is 0.10. And then we're just going to print that. So let's run this again. We're going to run the whole thing. Just going to take a minute. So there's a histogram of another sample. There's our graph. And the probability of between 2 and 5 is equal to 0.3 because 5 minus 2 was equal to 3, and 3 times 0.1 is 0.3. So let's change. We'll just do one more example here. Let's pretend instead of the interval from 0 to 10, suppose that the interval starts at 9 and goes up to, 22. I'm just, I'm just going to change A and B here to 9 and 22. And then we're going to go down here and we're going to calculate the probability of X being between, let's say 15 and 21. So between 15 to 21, we want to know that probability. So again, like all of this code can just be copied and pasted, but basically you get to set your A and your B here. And then when you want to calculate a probability, you put in those two values that you want to know the probability between down here at the bottom. So I'm just going to go ahead and click run again. And I want you to notice we're going to get a different graph now because we've designated different values of A and B. So now this is going from x equals 9 all the way up to x equals 22. And you'll notice that the probability has changed because the range of our values is larger. The width from 22 all the way down to 9 is a wider base of our rectangle, so the height of the rectangle is going to have to be a little smaller. And there's our sample that we took from this distribution. That is still a sample that looks relatively uniform. And then the probability for outcomes between 15 and 21 is apparently equal to 0.4615385. All right. So it's under half. So like under half the values are going to be between 15 and 21. So again, like this is just the uniform distribution, and we're using our code to calculate probabilities with the continuous uniform distribution. Like, subscribe, comment down below, share these videos with others if you find them useful, and I'll see you in the next video.